Hello, today we are going to do lesson 3.4 where we are going to solve a three-variable system of equations. If there are three variables, that means there are three equations. I'm going to refer to the steps as we go ahead and just do the example. The first thing we need to do is we need to rewrite the system as two variables. You need to decide which variable you're going to eliminate, and you need to do that 2 times with 2 different equations. So I said let's eliminate x. First, I'm going to use equations 2 and 3. I'm going to look at these two. The reason I chose those two is because x's just cancel very nice and easy. All I need to do is go ahead and add them. When I add them together, I get 8y plus 10z equals 74. Okay, now I'm going to do it again, but I need to use a different combination. So I'm going to do 1 and 3. I'm going to take the first equation. I'm going to leave that one alone. So I'm going to just write 3x minus 2y plus 4z equals 20. And I'm going to take the third equation and I'm going to multiply through by a negative 3. Again, please make sure you multiply all the way through, all 4 terms. So negative 3x minus 9y plus 6z equals negative 3. Once I add these together, my x's eliminate, so I have negative 11y plus 10z equals 17. Now, I have this equation and this equation. Now we have a system of equations with 2 variables. So step 2, we are going to solve the new linear system. So I can easily get rid of the z's by multiplying one of my equations through by a negative 1. So I'm just going to take the second equation and multiply through by a negative 1. I'm going to write it underneath my first equation right here. So positive 11y minus 10z equals negative 17. When I do that, I get 19y equals 57. Y then equals 3. Now we just go ahead and start substituting. So I'm going to take my 2 variable system and I'm going to substitute y into the top equation. That way I'll be able to find z. So I get 8 times 3 plus 10z equals 74. So I get 24 plus 10z equals 74. Subtract 24 from both sides. 10z equals 50, and z is 5. Now I'm going to take my z equals 5 and my y equals 3, and I'm going to plug it into one of my original equations to go ahead and get x. It does not matter which one you do. I think the work I have, I just did the bottom equation. I thought it was easiest. So I did x plus 3 times 3 minus 2 times 5 equals 1. And I was able to easily solve for x. I get x to be 2. When we write a system of 3 variables, we write it as an ordered triple. So we write the x first, then the y, then the z. This is how I want to see your final answer. So not too bad, but it's very easy to make a mistake. So really watch your signs, really watch your math. Write out your steps so you can see if you make a mistake. You can kind of go back and take a look. So let's go ahead and get started with the next problem. Okay, I'm going to go ahead and eliminate y's. I'm going to look at equation 1 and 2 first. So if I look at equation 1 and 2 and I want to eliminate y's, I'm going to multiply the second equation by negative 2. So when I do that, I'm going to just rewrite it here. X plus 2y minus 3z equals 50. Leave the first equation alone. Then the second equation is negative 4x minus 2y minus 4z equals negative 6. Go ahead and add those together. I get negative 3x minus 7z equals 44. Leave that alone. Now I'm going to go ahead, I'm going to take a look at the top, and I'm going to pick equation 2 and 3. So ignore that. Look at equation 2 and 3. I want to eliminate y's again. So I'm going to multiply the top equation through by 5. So when I do that, I get 10x plus 5y plus 10z equals 15. Then I'm going to leave my last equation alone. 2x minus 5y plus 4z equals negative, those are z's, not 7's, negative 79. I know my handwriting is messy, I'm sorry. Then I get 12x plus 14z equals negative 64. I'm going to take a look at my system of two equations, and it looks like it's easiest, doesn't really matter, but to get rid of x's. So I'm going to take this equation and I'm going to multiply through by 4. So when I do that, I get negative 12x minus 28z equals 176. So I end up with a negative 14z equals 112. So our z equals negative 8. Now, start substituting back in. Doesn't matter which equation you plug this in, so I'm just going to take the z, go ahead and plug it in over here. When I do that, you'll solve and you'll get x to be 4. Then I take a look and I look at the easiest equation to get y by itself. I think that happens to be equation number 2. So I'm going to go ahead and plug in my x, leave my y alone, plug in my z, and when I solve for y, I get 11. So we come to the bottom of the paper and we write our three variables, x first, then y, then z. Now, let's go ahead and try one more problem. I want to show you why we're going to try this problem because something unique happens here. So I'm going to take a look and I'm going to try to eliminate, let's say, x's. So I'm going to do equation 1 and 2. I'm going to multiply the second equation through by negative 2. So I have 2x plus 4y plus 10z equals 14. Negative 2x minus 4y minus 10z equals positive 8. Look what happens here. I end up with 0, 0, 0. Everything cancels out, but on the right I end up with 22. Is this true? Does 0 equal 22? No. So this system has no solution. At any point during the process, if you get a number not equal to another number and all the variables cancel, it's no solution. Sometimes it happens later on in the process, sometimes it happens at the beginning. Now, if you get a situation where the left side equals the right side, we know that that would be infinitely many solutions. So you can have the same thing happen as a system with two variable equations as it did with three variables. Now, I would like you to take a look at this last try this problem on your own, watch the math, and if you have questions, comments, or concerns, I will see you tomorrow in class.